Hey there guys, Mr. Hames here. We're going to go through Newton's first law of motion. Newton's first law says this: an object will keep moving with the same speed and direction unless acted on by a net force. Before we can understand this, I just want to go through this idea of net force. So, net force. An object with zero net force means that the forces are balanced. This means that the object will either remain at rest or keep moving with the same velocity. In other words, its acceleration is zero. It's neither speeding up nor slowing down. If we look at the two girls here pulling against each other, you'll notice that the forces are balanced. These girls are pulling with 100 newtons to the left. These girls are pulling 100 newtons to the right. Therefore, net force is equal to zero, because if we add these together, we get zero. Forces are balanced. Therefore, this tug of war rope will remain stationary. So objects that are stationary will remain stationary. So if I have a rock, this rock here will remain there because the forces are balanced. Okay, unless we pick it up and exert an unbalanced force on it. In the example of the car here, I've got 10 newtons of driving force going to the right, 10 newtons of friction or air resistance going to the left. These forces are balanced, so this car here will continue in constant velocity unless an unbalanced force is acted upon it. Okay, so these are the two examples when net force is equal to zero. An object with a net force acting on it accelerates in the direction of the net force. So again, we'll use these girls as the example. We've only got one girl on this side now, so we've got 50 newtons to the left and 100 newtons to the right. So if we were to add these two vectors together, we would get a net force of 50 newtons to the right. So therefore, its acceleration will be to the right. So this rope here will accelerate to the right because there's an unbalanced force acting upon it, and that is 50 newtons to the right. For example, of this car up here, we've got 10 newtons of driving force to the right, 7 newtons of frictional force or air resistance to the left. Therefore, we'll have a net force of 3 newtons to the right. Therefore, the car will be accelerating to the right. So if the net force is not zero, the object will accelerate in the direction of the net force. Newton's first law of motion, so an object will keep moving with the same speed and direction unless acted on by a net force. And we discussed whatever direction that net force is will be the direction of the acceleration. So an object at rest will stay at rest, an object of motion will stay in motion unless acted on by a net force, or unbalanced forces is very common to see as well. Inertia. Inertia is the natural tendency of an object to maintain its velocity. Remember that an object's velocity is its speed in a certain direction. We can sum up the idea of inertia by saying that it's important to remember that inertia is not a force. It doesn't act on an object to make it stay still or keep moving. It's just a property that all things with mass have. So I actually like to call this the teenager, okay, the teenager rule. Why? Because a teenager wants to maintain its state, okay? Wants to maintain what it's doing. So the teenager in bed in the morning doesn't want to get up. It wants to stay in bed. So if I have a car traveling this way and then suddenly it brakes, the teenager on top of the car, this object here, wants to continue in its state of motion. So the TV or is it a microwave, I don't know, let's just call it the teenager. The teenager is in bed, it wants to stay in bed. the microphone wants to stay in motion, so it'll continue and fly off the top. So that's why we need to tie things down. Okay, otherwise our object will just continue in at the same speed that it was traveling. The teenager will stay in bed if it's in bed. So an experiment we can do to prove this, we've got a coin on a piece of card. Quickly pull the card out, and then the coin will just drop into the water. Okay, the coin won't go with the paper because it's resistant to change. Just like the teenager, it's resistant to change. Okay, so the teenager is in bed, it wants to stay in bed, and you'll notice that the coin will drop into the water. Finally, we always like to apply car crashes in the case of inertia. So that's why we have to wear our seatbelt. But let's say if this guy wasn't wearing a seatbelt, what would happen if the car crashes? So the car crashes, the teenager is resistant to change and wants to continue at the same velocity it was already traveling at. So the person in the car, when it crashes, will continue at that same speed, 27 meters per second. And if we didn't have an airbag and we didn't have a seatbelt, imagine what would happen to the person's head. Might just fling straight through the window screen. Okay, so that's why we need airbags, and that's why we need seatbelts in cars, because of this inertia. The teenager rule, the object is resistant to change. Okay, so the object will continue at the velocity it was traveling at. Just imagine like a big rock. So I've got like this massive boulder, okay, and you try to move the boulder. It's nearly impossible because the rock is resistant to change. The teenager wants to stay in bed. Okay, the teenager is resistant to change, therefore it would be really hard to move the rock. So hopefully that helps. Thanks for listening. Good luck with today.